Good afternoon, and thank you for joining me for leveraging UAS to map invasives along the transmission right-of-way. My name is Ron Behrendt, and I am the Managing Director of Behron, LLC. Our company provides geospatial consulting services and focus on remote sensing such as LiDAR and imagery, and especially integrated with drones. We were founded in 2005, and we're based out of Whitefish, Montana. So let's begin by answering the question, what is an unmanned aircraft system, or a UAS? Well, it starts with an unmanned aerial vehicle, a UAV, also often referred to as a drone. They come in a variety of different types: fixed wing, rotorcopters, vertical takeoff and landings, and they have a variety of different types of propulsion systems. The most common that we see in the electric utility industry are electric, but there's also liquid fuels, hybrids, and hydrogen. So as you can see, there are a wide variety of types, shapes, colors, capacities, capabilities. These are fixed wings, some foamy wings, some that look like helicopters, different types of rotorcopters, 4 blades, 8 blades. They just do come in a whole variety of different types and styles and capabilities. So we start with the UAV, and now we need to add a sensor to it. We have a variety of different types we can add. Just basically imaging sensors, true color multispectral, LiDAR, thermal, and so on and so forth. And now we're starting to see actually multi-sensor payloads where we have one or several, or more than one or several sensors. So why map invasives? Utility right-of-ways are transportation corridors, enabling spread of invasives or noxious weeds more easily than in a natural landscape with significant potential impacts. Historically, satellite remote sensing has been used to be able to identify and monitor invasives. However, it has challenges to be able to resolve detail in enough level to do actual invasives mitigation. So why map invasives with a UAS? The improvements with the sensor technologies on drones, the software, and the drones themselves have allowed us to efficiently get a level of detail that has never been seen before, as well as do wide area coverage. This can be used for things like change detection, and the detail that we can see in this type of remote sensing allows us to actually look at things on a tree or a plant level, and that is the level that often mitigation needs to be performed. So the project I want to introduce you to is a project done for EPRI's P51 group, and the goal was to be able to see what kind of applications we could perform with a UAS and multiple sensors. And the site that we worked on was up in outside of Toronto, Canada, and we flew it in October 2019. The specific invasive that we were working to identify and map in this project is known as Phragmites. As you can see from these photographs, it's a relatively tall, reedy plant, and it's most often found along different water bodies, wetlands, rivers, streams, things of that nature. For the project, we utilized both a multispectral sensor as well as a LiDAR scanner. We went out in the field and we identified and found some Phragmites infestations and logged them with a GPS receiver. We could then take that information and correlate it to the multispectral imagery. But in addition to the spectral signature, we were also able to put a height mask in, and we were able to eliminate anything that had similar spectral responses but were shorter than 2 meters in height or taller than 4 meters in height, because we knew the Phragmites would be within that range. So we actually had 6 bands of information to work with, the 5 multispectral bands, and then the height raster that we created from our filtering. So we did find small clusters of Phragmites in the area. Unfortunately, we also ran into a lot of false positives, and we believe that had to do with the fact that we were capturing this data in the fall. It was October, and ideally it would have been best to capture this data when the Phragmites was in a more vigorous growth path or time, and that would have been probably the May through July timeframe. So here we were able to map it and be able to display it in a way that allows you to be able to see both the quantity and the location of the Phragmites. We can take a higher resolution look at it, and you can see you could actually go onto the ground here and be able to possibly perform mitigation efforts. So where is this going? One of the primary things that will happen in the relatively near future is the ability for a drone or a UAS to fly beyond visual line of sight. With very few exceptions today, most drones are only flown visual line of sight. And what that means specifically is the pilot in command must always be able to see the drone. And that prohibits efficient use of a drone or a UAS in long linear applications such as transmission rights of ways. But once that regulatory constraint goes away, that will allow us to do much, much more efficient collections. Automation to handle this new wave and stream of data will be very critical to be able to efficiently and quickly go from raw data through analysis and into results. And that's most likely going to be powered by artificial intelligence and machine learning. Change detection and highly automated change detection will become a very important type of analysis for invasives in particular. Not only do we want to identify them, but then we need to track them over time. If we do perform mitigation efforts, what were the results? And last but not least, storing and managing these large volumes of data and specifically sharing them in a visual and easy to use type of way, which is today referred to as WebGIS, will be absolutely critical into sharing the results. So in summary, UAS can provide high resolution, high quality data for rights of ways, which can have great application for mapping things at higher scale, such as invasives. And cost and speed are always a factor. But because of advances in the technologies, improvements in the regulatory environment, we think that the UAS will be a good candidate to do this in the very near future. Thank you, and I'll be happy to answer any questions.